Hi, my name is Roundsa. I'm presenting a paper about the origins of the S-process enriched star HD 55496. Did it originate from a globular cluster or from a tidal disruption of a dwarf galaxy? Let's dive in. The star in early observations was believed to be a barium star, but was later considered to be a metal-poor barium star. Barium stars are very useful targets to constrain the nucleosynthesis process in asymptomatic giant branch stars, or AGB stars, which was the initial reason that this star was studied so deeply. However, from this analysis, researchers found many chemical peculiarities. From analyzing this star, researchers found 4 big chemical peculiarities. As an overview, there was a sodium-oxygen abundance anticorrelation, and the star was rich in aluminum. For an S-enriched star, it was severely lacking in carbon, and the heavy second S-process peak elements present showed way smaller abundances than the light S-process elements, when normally these numbers are the other way around. Our star, HD 55496, is represented by the red star on the 2 ratio diagrams, here and here. In the figure, it's apparent that the star is extremely rich in aluminum and high in sodium compared to oxygen when compared with field stars of similar metallicities, as seen from the other points on the diagram. The carbon abundance is also low when compared to an S-process star of similar metallicities. However, the carbon and nitrogen abundance sum shows an enhancement compared to stars with similar metallicities, as seen in the figure below. The value of C plus N means the star did not experience the triple alpha process, which would result in a carbon enhancement. Therefore, this star is not at the AGB phase. In addition, the carbon-oxygen ratio gives more evidence that HD 55496 is not carbon enriched. For a star to be considered an escape globular cluster star, the abundance of the S-process elements is the most vital aspect to observe. The light S-process elements show a very high abundance, as seen here, with a mean of a light to iron ratio being 0.96 plus minus 0.26. The abundances of the heavy S-process elements provide a lower heavy to iron ratio, which is 0.46 plus minus 0.14. Therefore, the heavy to light ratio is negative 0.5 plus minus 0.30. In addition to the S to iron ratio, where S represents the mean abundance of the S-process elements, it is 0.80 plus minus 0.28. This explains why HD 55496 was previously classified as a barium star, which we spoke about on our first slide. The graph here shows a comparison between the heavy to light element ratio against an iron-hydrogen ratio. On this graph, the red star represents HD 55496, the black crosses represent barium giants, and carbon-hydrogen stars are represented by magenta squares. Other outliers are represented as the other values. From this data, it's obvious that our star is not a barium giant, a carbon-hydrogen star, a yellow symbiotic star, or a binary CEMP-S star. The next place to check was among the AGB models for low metallicity. In the figure, the position of the star is shown as a red star in both diagrams. Heavy to light S-process elements and lead to heavy element versus iron-hydrogen abundance is shown in our diagrams, as seen. Based on the star's position among both of these models, it is clear that the abundance pattern can be represented by 5 to 6 solar mass AGB star, as seen here as 6 and as seen here as 5. All the peculiarities suggest that HD 55496 is actually a second generation of globular cluster stars. A second generation globular cluster star means that the star was formed from gas already strongly enriched in S-process elements. These stars present an anticorrelation of the abundances among light elements, which follows the same patterns found in the chemical peculiarities of this star. However, such patterns and anticorrelations between these abundances have not been observed in the past among halo stars of such low metallicity. Therefore, any star found in the field halo of the galaxy presenting such an abundance pattern could be considered as a second-generation candidate star of a globular cluster that has escaped. However, this is very rare, as being able to observe these clusters has a very low probability occurrence of about less than 6%. In conclusion, based on the chemical and dynamical analysis of HD 55496, we can hypothesize that it may have originated from a globular cluster. However, considering its retrograde motion, which was briefly mentioned within the paper, it may also be a halo intruder that possibly originated from a tidally disrupted dwarf galaxy. Due to the star's strange values and low encounter probabilities with globular clusters, the origin of this star is left open to further analysis. Onto the press release. This press release gave a great summary of the paper, detailing the main points of the article without being inaccessible to a more general audience. I would have liked more images and a better explanation of the graphs. Thank you for watching, and here are my sources.